everyone. So I'd like us to take a practical example so that we buttress what we've learned about buoyancy factor calculations. So in this particular question, they said calculate the weight of 5,000 foot of 13 and 3/8 inch casing. Now the weight of that casing is 68 pounds per foot in air, and we also want us to calculate the weight in 10 pounds per gallon mud. So quickly, let's calculate the weight in air. The weight in air is going to be simple. So you just have 5,000 feet 5,000 feet times the weight, 68 pounds per foot. It's always good to pay attention to the units, but because with the units, you can actually know what to multiply, what to divide, and get your final answer. In this case, this cancels this. So your 5,000 multiplies 68 pounds. So we have 5,000 times 68. And when you do the numbers, you get it easy. It will be 340,000 pounds. This is the weight in air. So quickly to calculate the weight in 10 pounds per gallon mud. So we will first calculate the buoyancy factor. Guys, don't forget the buoyancy factor is the weight of the material, which is that in this case steel, minus the weight of the fluid, sorry, the density of the material minus density of the fluid divided by the density of the material. So in our case, buoyancy factor is going to be the density of the material is 65.5 minus 10, that's the weight of the mud, divided by 65.5. So buoyancy factor is going to be 55.5 divided by 65.5. So if you check this quickly, 55.5 divided by 65.5 is going to give us 0.847, and this is the buoyancy factor. So when you multiply that by the weight in air, so your weight in mud, that's 10 pounds per gallon, is going to be 340,000 times 0.847. So quickly, that gives us 288,000 288,091.6 pounds. So if you look at it quickly, you see that this weight, the weight in mud, is less than what you have in air, and this is as a result of the buoyancy factor reducing the weight. Thank you very much everyone for watching. Bye for now.